Hello everyone. So on this episode, let's explore a little bit of what this wasm means. So why do we want to build on wasm? Why do we want to build BTFS on wasm? So basically, what is wasm? Well, it's the abbreviation of WebAssembly. What the hell is WebAssembly? So WebAssembly is a low-level assembly-like language with a compact binary format that runs with near native performance and provide languages such as C, C++, and Rust, and many other, included Go, which is the language that BTFS uses to develop their tools. So it basically WebAssembly is compatible with all these languages. Of course, these languages has to implement uh, certain functionalities so you can compile them as a WebAssembly binary. But anyhow, the most important part of this is that you can run actually this binary into a browser. So we're used to two kind of, let's say, applications. One is a web or online application, which basically depends on JavaScript, HTML, or any other language which is compatible with a browser. But the interesting part of WebAssembly is that you can basically run. It's the performance is near to native. What native means? It means a code or a binary file that you execute in your machine, which is super efficient. Let's say it's a machine code, right? Okay, we can talk about like that. Um, so these kind of binaries are like are really a revolution into a web development, and basically the meaning of or the purpose of having a WebAssembly binary for BTFS is so we can run a BTFS client or BTFS node fully on the browser. Maybe you can imagine this as a future Chrome plugin that you can install on your browser, and basically you don't need to download a weird binary from BTFS and then given permissions and then execute and then figure out how to manage the command line if you're not an experienced user, things like that. Okay, so it's super clean, you don't have to install anything, and the more important thing is that you do not sacrifice performance, because of course you could somehow rewrite the go-btfs code into a JavaScript, for example. And right now you can see that for IPFS we have different releases or different projects running on called like JS, IPFS, something like that. But that definitely reduced performance. And the beauty of Go is that you have a nice language and also super efficient. The performance of Go is nearly as close as C or C++, which is really good. And with WebAssembly, you are removing, let's say, the inefficient part of a web development or web language. And because at the end it's interpreted, JavaScript is interpreted, meaning you have like several layers, layer over layer of code or architecture in the software. So that definitely reduces performance. So okay, enough of the introduction. So the idea on this project, it's a proof of concept. Of course, it's not functional right now, but at least we had a huge effort and a significant effort. So we can say we updated the dependencies on go-btfs to support WebAssembly. A lot of Go files were not expecting Go compiler to to compile the on wasm, so I needed to modify such files, such the source code. Basically, it actually compiles right now, and the daemon starts and can interpret basic commands. However, we cannot use the file system as it is, because right now go-btfs is highly dependent of a file system, meaning actually storing data in your hard drive. So that's basically right now the major hype cost on this. So let's download the BTFS wasm. So it's also available in my GitHub page. You can go here into the releases, download the code, the binary file, and also download the full repository, because we will need it to test it. You can download the source code here, or you can go to the main repo and just select the wasm branch and just click here, and you can download it using Git. If of course all this conversation here is more focused on for a web or a web developer or Go developer. So yeah, let's go here. We already downloaded the wasm file. Let's copy that and let's go to our BTFS shared lib repository we have here. And I created a new folder called wasm test. So what we are going to do is to just paste the wasm file here, which we downloaded from the release page. And let's first start our HTTP server. You can use whatever server you like. I use the Python 3 HTTP server, and just make sure that you are located into the wasm test folder. So we are gonna cd wasm test and then execute your server here, HTTP server, and we are ready to go. So we are listening into the 8000 port. So I'm already here. Let's open the development window. Where is it? JavaScript console. Okay, so if we refresh the page, something should go around here. Okay, no. Okay, let's run the BTFS daemon and let's see how it goes. Of course, we're having a bunch of errors, but as you can see, the daemon tries to initialize. I included a couple debugging messages here. It's not an error, it's basically a debugging message here. So I was just testing the file system and how I could manage to overcome these difficulties. At the end, it's starting, but as you can see here, make dir is not implemented on JS. So meaning all these operative system and file system goals from Go are not prepared for WebAssembly. So we have to think of a workaround. So we can have this repository, the BTFS repository initialization, by using a WebAssembly format. So okay, so this is the current status. I already explained how to download and run this. I hope in the near future we can have a minimum viable product. Right now it is in the proof of concept phase. So any kind of contributions or ideas that you might have are welcome. And that's it. Thank you, everyone. Bye-bye.